Welcome to part 2 of Parabolas, 5.1 in our Integrated Algebra 2 here. So we're going to just continue the examples that we started in part 1. This is just going to complete the examples from our notes. So we're going to start off today with example 3. Alright, so we have find the standard form equation for the parabola with a focus at negative 6, 4 and a directrix at x equals 2. Alright, well, as usual, we're going to start with graphing what we know. So we have a focus at negative 6, 4, so I'm going to go over to negative 6, and I'm going to go up to 4, and because this is a focus, I'm going to draw a little x there. Alright, we just draw an x for our focus just so we can see the difference between that and our vertex. Alright, and so then we also have a directrix at x equals 2. Alright, so x equals 2. Well, x equals 2 is over here. This is x equals 2, this line right here. So now we have our first example of a sideways opening parabola. Alright? As we can see, if the line goes up and down, it's going to have to be a sideways opening parabola. So what I can do is I can look at the distance between x equals 2 and negative 6 of our focus. That's going to be 8. So I can move 4, 1, 2, 3, 4, and that's going to be our vertex. And again, we can check it by just moving the same distance from the directrix. So 1, 2, 3, 4, we just found our vertex. Alright, and our vertex looks to me to be at negative 2, 4. Alright, so I'm just going to label that. Alright, well now we can go ahead and draw our parabola. We're going to have, the arms have got to go around the focus away from the directrix. So it's going to look something like this. And again, doesn't need to be perfect, it just needs to get the idea right now. We're not trying to find specific points, but that's pretty much what it's going to look like. Alright, so since this is a sideways opening parabola, we're going to have to use our other formula to work with this. So we're going to have to use this formula right here. X minus h equals 1 over 4p times y minus k squared. Okay, so now we're going to go ahead and we're going to work out with this. Alright, so we have, let's see here, let's get a different color out. Let's go ahead and get green, just like our sideways opening. So we're going to have x minus h, which our h is going to be just, again, the x value of our vertex, which is not going to be right there. That's our focus. We're going to have to go right here. So we're going to have negative 2 is going to be that. So a negative 2 is going to be plus 2. All right. We're going to have equals 1 over 4 times p again, just like with the y, just like with the opening up and down, it's still 1 over 4p. And our p is going to be what? It has to be a negative because we're moving from the directrix 1, 2, 3, 4 in the negative direction. So we're going to have negative 4. For our p. Then we're going to multiply that by y minus k, which our k value is going to be our y value at our vertex, so it's 4. So we're going to have minus 4 squared. Okay, so then we're going to go ahead and just simplify this out. We're going to have x plus 2 equals a negative 1/16 times y minus 4 squared. So again, now we can go ahead and say that we have our standard form, don't we? And here it is right here. We just have that whole thing is going to be our standard form equation. Okay, so it's not too bad doing the other way. I mean, it's the same sort of process. We're just plugging and chugging for most of it once we find our graph. Okay, so now we're going to continue on with example 4. We're going to find the standard form equation for the parabola with a focus at 6, 2 and a vertex at 3, 2. So I'm going to go to 6, 2 right here, and because it's a focus, I'm going to draw my X right there. We always just draw a focus with an X, just so we can differentiate between the vertex. So then we're going to go to our vertex at 3, 2, and I'm going to draw my circle right here. A little bit bigger than usual, but you get the point. Okay, and so we know that the distance between them has got to be P, and we know that the directrix has got to be that same P from the vertex to the directrix as it is from the focus to the vertex. So we're going to have 1, 2, 3, it looks like right there. So we're going to have 1, 2, 3, and it looks like here's our directrix during this for this example. It's just going to go right along the x equals 0 line. Alright, so now that we have our x equals 0, we know that this has got to be a left and right parabola because of the fact that the points are moving left and right. So we can go ahead and draw our parabola, what we think it'll look like. It'll look something like this. Again, as usual, not perfect, but we're just going to make a good representation of it. It's going to wrap again around the focus. So you see these arms going around the focus, and it moves away from this directrix. So it's moving constantly away. So now that we know that it opens to the right, we have to use our formula for if it's right or left instead of up and down. So it's going to be this formula right here again. We're going to have x minus h equals 1 over 4p times y minus k squared. Okay, so again, same sort of thing again. We're just going to plug in some values. Okay, so we're going to have x minus h, so h is the x value at our vertex, which that's going to be 3 right here. So it's going to be minus 3 equals 1 over 4 times p, which our p on this case is 3. It's 1, and if we go from the directrix, so 1, 2, 3, 1, 2, 3, it's in the positive direction. So we're just going to put 3. Times y minus k, which is again our y value at our vertex, which is going to be 2. And we just have to square that whole thing. So we're going to simplify and we'll be done. So we have x minus 3 equals 1 over 12 times y minus 2, and that whole thing squared. So again, it looks like we have our box right there. That's our standard form equation. And we've finished example 4. That's all they wanted. So again, another example of a sideways opening parabola, and again, it's not that much different than our up and down opening. We just have to use the different formula. Alright, so now we're going to move on. So we're going to move on to example 5. We're going to find the vertex, focus, and directrix for an equation. Instead of the other way around where it gives us 2 points or a point in the directrix, we're going to give the standard form equation right here, and we're going to have to find our pieces. So first thing is our vertex. Okay, so our vertex is going to be, this is x. We're using our x minus h formula right here. So this has got to be the x value at our vertex. And because we minus it, we're just taking the positive 2 right here. So it's going to be positive 2. Alright, and then we get our y value from this right here, y minus k. And because it's a positive 1 right here, we're going to use a negative 1 in our vertex right here. Alright, so we can go ahead and graph that. It's going to be 2, negative 1. There's our vertex. Okay, so now we need to find our focus and our directrix. And I'll just put a D for directrix. Okay, well, so we need to find our P. Well, our P is going to be found by taking this value right here, this 8, and we know that has got to equal to 4P. Okay, just from looking at the equation, the formula that we've been using. So P is going to be just 2. Now, because it's a positive 2, we know that it's going to move to the right or it's going to move up. But we've got to look at our equation, and because this starts with an x, we know it has to move to the right. This is a right or left opening because we use the x first equation, and we know it's a right opening because this is a positive 2. So I'm going to move 2 to the right of my vertex, and that's going to be my focus. All right? And then I'm going to move 2 to the left of my vertex, and that is going to be my directrix. So I'm just going to draw my directrix line up here. Again, always make sure your directrix is dotted because it's not part of the graph, it's just how we find the graph. I can go ahead and put my parabola right here. Go ahead and do the arms of the parabola. They're going to wrap around my focus again right here, and they're going to move away from the directrix. So with this, now I can tell all my points. So I can go to my focus, and that's going to be 4, -1, which, because we're moving left and right, it's a left and right opening, our y shouldn't change between our vertex and our focus. That's a good way to check. It's a right opening. Left opening would be the same situation, that your y value should not change. All right, now our directrix, that's going to be an x equals line because it's up and down, and it's going to be x equals 0. All right, and now we found the 3 items that we needed to find. And yeah, we're